Hello there, I'm Thomas Hatsios, a German-American pilot flying the Boeing 787-900. Tonight's flight we're going to be over from Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 for an Lszh localized at landing. So I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display. That displays the airspeed indicator, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the altitude indicator, the artificial horizon, the pitch ladder degrees, and the bank angle in degrees. The Lszh localizer will have the horizontal localizer and vertical glide slope that receives the radio frequency transmitted from the antennas of the threshold runways. We use for takeoff and for landing. So we have the Zurich International Airport runway 14. We're gonna use this Lszh localizer frequency, and we're gonna use the magnetic heading of 136 degrees of the runway for alignment. So we have the localizer and the glide slope, and the Lszh localizer crossbar. So we have the localizer, also the onboard antennas that receive the radio frequency transmitted. So we have the flight director crossbars for manual guidance of the aircraft, and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode annunciator with autopilot and the auto throttle. Later on vertical navigation modes. We have also the HSI. The HSI that displays the horizontal situation indicator. We have the magnetic heading and track, and the integrated display with the flight plan. So we're gonna create a flight plan. You're gonna see how we're gonna do that using the flight management computer after a few minutes. So I'm gonna show you also the navigation display. The navigation display that displays the GPS position of the aircraft, the magnetic North Pole and geographic North Pole, and the magnetic variation depending on where you are in the world. We have the terrain map with the airports. You can see the airport we are located right now. The runways also we're gonna use for takeoff and for landing, the taxiways. Also we have the terrain and weather reflections on the weather radar. You can see the terrain around you, the elevation with red, green and yellow. Reflections, you can see also the road stations, the ATFs, the NTPs. We have also the waypoints which are horizontal and vertical navigation fixes the aircraft can fly through. During the flight we're gonna select some from the flight management computer. You're gonna see also displayed with a purple or magenta line connecting them in a flight plan or flight path or route. So also you can see in the navigation screen we have the horizontal and vertical profile of the aircraft as we fly. You can see also we have we're gonna have also other aircraft displayed. We have the transponder, the DSP and DC transmitter receiver that transmits our frequency to other aircraft, and the air traffic controller receives from other aircraft in the air, and can calculate using the radio frequency the other aircraft, where they are located, the distance from our aircraft in nautical miles, whether they climb or descend with respect to our aircraft, the altitude difference between our aircraft and the other aircraft, and also the velocity closing in between our aircraft and the other aircraft. It will give us a warning from the TCAS system, Traffic Collision Advisory System, and we have an incoming collision with another aircraft in the air or in the ground. So we have also all these things you can see. I'm gonna show you the autopilot flight director system panel, the engines indication, the thrust levers, the flight controls. You will see how I'm gonna use all the flight controls using the side stick here, the load stack in 3D. So you can see I can climb or I can descend. I can make turns to the left and turns to the right using the control wheel. Also the rudder pedals. I have here the control of the rudder, the vertical stabilizer. I have the horizontal stabilizer, the pitch axis for climb descent, and the ailerons and spoilers, and flaperons for the roll axis for making left and right turns. So you can see also I'm gonna show you the outside view of the aircraft and its functions, the flight control. So you can see here we have the displays. You can see we have the navigation display, the horizontal and the vertical profile over here as we fly. So we have here the primary flight display. You can see the airspeed indicator right now, the airspeed tape, the airspeed selected from the autopilot flight director system panel, the altitude selected from the autopilot flight director system panel, also the barometric altitude 1430 feet above the ground level we are located right now, the vertical rate of climb descent of the aircraft is 100,000 feet per minute, the vertical speed indicator, so you will see this needle moving up when we climb or moving down when we descend. We have the radio altitude right now above the ground level, -2 feet. The barometric pressure of the outside atmosphere, 29.92 inches of mercury, and the radio minimum. So we fix, we can select the barometric pressure over here. You can see bar set inches of mercury or hectopascals over here. Minimums baro, also over here plan range. With the radar, traffic and terrain on the display. Also we have some warnings here, cancel, reject, accept. So you set inches of mercury or hectopascals for the barometric pressure, to have the barometric altitude selected over here, depending on the barometric pressure of the outside atmosphere. You have the radio also to give you an idea when you fly. So you can see also here we have systems, CDU info, checklist, communications, navigation display, engine. Right now we can change one display or another. So we have the indications that we need to know, the engine, and one which is the low speed starter, sub low pressure compressor, and turbine of the turbofan, which is engine, exhaust gas temperature per engine, and 2 which is the high speed starter, sub the high pressure compressor or turbine of the turbofan, 2 which is engine, the left and right, fuel flow per engine per hour, 1000 kilograms to 1000 pounds per engine per hour, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have the cabin altitude for the differential pressure for the pressurization of the aircraft, the rate of climb descent. It can go like 8 psi, the differential pressure, and the cabin altitude 8,000 feet when we climb to 43,000, maybe more, 45,000 feet. Landing altitude manual forward and aft, the outflow valves. So we have also the display of the flaps here, landing altitude here. You can see external retract and rudder trim and stabilizer trim, gross weight for takeoff, and total fuel on board right now, and the fuel temperature and the saturated air temperature. So I'm gonna show you a few more things from that. So you can see also here in the primary flight display, we have the altitude indicator, the artificial horizon, the pitch ladder in degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down altitude. So you have to pay attention both this and this, whether you climb or descend. Flight mode annunciator with the autopilot and auto throttle. Right now we have the takeoff go round mode set. The HSI here, the display heading also selected 360 degrees, and the ADFs left and right. So you can see also the navigation display. As I told you, the range right now is 80 nautical miles. The heading magnetic 320 degrees, ground speed. We can select also other things here. You can see some airports, our own airport. Also the aircraft symbol right now. You can see the vertical when we fly, how far above the ground we're gonna be flying through. So we have also the head-up display for this. I'm gonna show you the overhead panel, the systems. We're gonna need to start the engines later. Also, I'm gonna show you the autopilot flight director system panel. You can see we have the autopilot engage and disengage switch, the flight director, auto throttle left and right, The airspeed guidance I will set later. LNAV and VNAV. Heading guidance over here. Vertical rate of climb descent. Altitude selected. 10,000 feet. So you can see 200. The airspeed 360 and 10,000 is the same one as displayed in the primary flight display, the left and the right over here. So you can see 200 knots and 10,000 feet as the autopilot selected here and here, and the heading also 360 degrees. So we'll change the settings later. You will see also the flight management computer over here. This is also the auto brake we're gonna set if we need for landing for ejected takeoff. The flight management computer here, you can see the display of the CDU, control display unit. I have the keyboard here to input the values I need, the systems. I can make a selection of another display. I have the mouse pad here also. You can see I can use the mouse pad to control the inputs I want to do here. So I use my mouse pad here, as you can see, to make the selection of the control display over here, instead of using this in here, which is same like the original aircraft. So you can see I can select here from the index, identity, position, performance, takeoff, approach, annunciate status, navigation data, flight plans, load the traffic control route, save plan, save flight plan. So we can select either display indication. Later you will see how we're gonna make that, and make a flight plan using the flight management computer, flight plan, and the data for takeoff later. So you can see also here the display. We have the touch screen over here. You can select using the mouse pad here. So I will show you also here. So you will see the thrust levers also, how to use all the thrust levers I have here for controlling the engine's thrust. So you can see the engine's thrust over here, moving forward enough. So this is the engine's indications, as you're gonna see later. I will explain, I'll give you a better explanation. You will see the thrust increase. You can see we're not configured for takeoff right now, so I will use the idle thrust again. We have also the auto throttle disconnect switch over here, the takeoff ground switch, and the thrust reversers. You pull up and reverse the thrust. We have the fuel control for the left and the right engine. Fuel flow, you can cut off the engines or start them. Later you're gonna see how. We have the engine left and right fire. We pull out and switch the fire control, fire extinguishers. We have the transporter here, the rudder trim, radio and communication panel over here. Also you can see the stabilizer trim cutoff switch and the pitch trim for the horizontal stabilizer. I will explain in a couple of minutes. Part of the flight controls, the parking brakes here. So I will use the stabilizer trim, the navigation and communication radios, ground proximity warning, weather radar, transporter here, frequencies. So you will see all the systems we have. So we have also the flaps extended. I will show you how. You can see the flaps handle over here, retract or extend the position that we need. So you can see over here the flaps. You can retract or extend. So you will see, if you look outside, the flaps now are retracting. are moving in. They can be fully retract, as you can see. They keep moving. So you can use flapless, like 5 degrees, or you can extend all the way down, like you see, like 30 degrees, moving down this handle here. So you will see now the flaps are extending, both wings, and the slots also. So you use this handle to control this. Also we have the speed brakes over here, so you can see the speed brakes also, which act also as flight spoilers. So we have many things yet to see. I will show you also the pitch string, the horizontal rim stabilizer. So this is a fly-by-wire aircraft. It has a flight control computers when we fly, like in the Airbus. So you have the normal, the alternate, and the direct mode of control of the flight control computers. Also we have an automatic trim of the horizontal stabilizer, the horizontal tail of the aircraft, the elevator, horizontal pitch string, which pitch the nose of the aircraft up or down, depending on what we want to do in flight, how we want to control the aircraft. So you'll see how we will control also the horizontal pitch string over here. So you can see here we have the flight control computers, primary flight control computers in the auto position over here. We have also other things, there data computer, flight control surfaces. So you can see here, for instance, we have the manual trim of the horizontal tail. You can see the control wheel. So this switch is for controlling the elevator pitch string. This way you pitch the nose up, and this way you pitch the nose down as you fly by trimming the elevator up or down, either way. You can see also the flap speeds over here, other indications. So this is the elevator pitch string. So elevator pitch string. Left click down, right click up, as you can read here in the tag. So this is elevator. This way you trim the elevator up, this way you trim the elevator down. You do the same effect for the nose of the aircraft as you fly. You pitch up and pitch down. You have the head-up display, declutter, and the autopilot disengage switch here. You have 3 functions. You control using the side stick over here, or the yoke. So I have a side stick like in the Airbus aircraft. So I control the elevator for climb descent, the elevator pitch string. But I'll just show you this switch. I have it here, so I can trim the elevator, the horizontal tail up and down. We have also, as I told you, the autopilot and flight director and auto throttle systems. When we fly, we have the automatic trim, which acts on its own. We have the normal, the alternate, and direct low of the flight control computers. So we have also here, as I told you, the flight control computers, primary flight control computers. So we have a failure of hydraulics that affects over here. You can see, I'm gonna show you later as we move on. That affects the horizontal trim stabilizer from the autopilot and flight director system panel, the auto trim function of that. You have to come down here and open this red carded switch. You can see stabilizer trim to an R2 from normal to cut off. This switch you can see. So this is for all Boeing 737, 747, 757 767-327 Boeing 787. If you have a failure of the hydraulics that affects the L2 or the R2 horizontal stabilizer and elevator trim, you disconnect from this switch, so you lose the auto trim function. That's also you have only the manual, the alternate over here, alternate trim, so you see nose up or nose down, the aircraft alternate pitch trim as it says. And you also have, you can see the parking brakes also here. You also have the manual trim all the time over here, the manual trimming for the horizontal elevator, for climb or for descent of the aircraft as we fly. So this is what it's doing. Also we have the flight management computer. It gives inputs and data to the autopilot flight director system panel, flight control computers, wing flight thrust control, the FADEX. We have the FADEX for the thrust control, the full authority electronic control computers. I will explain that also, its function. So we have the horizontal elevator here, as you can see, in the horizontal stabilizer for flying the aircraft. You can climb and you can descend, moving the horizontal elevator for climb or descent like this. Also use the rudder pedals for making left and right turns. So you can we can climb and we can descend using the elevator, as you can see. So this is the pitch axis over here, the lateral axis. So I will talk to you now about Newton's physics, aeronautical and aerospace engineering, and Newton's physics and aerodynamics, and also the Bernoulli theory of fluids. And I will show you some principles we need to know about flying the aircraft, the Boeing 787 or any jet aircraft. So I will show you the outside view of the aircraft and show you how the aircraft flies with the aerodynamic forces. Also the use of the engines, for instance. So you can see here the outside view of the aircraft. You can see the surface area of the wings hold the weight of the aircraft as we fly. You can see we have the mean aerodynamic chord position, the Mach, which is 23% of the mean aerodynamic chord for this aircraft. Is the position with the maximum aerodynamic lift occurs in the forward wings. Is also the position with the stall. The airflow becomes detached from the top surface all the way back as we fly. Also is where the center of pressure on the top of surface of the wings is moving forward or aft, and also where the center of gravity is located down here. So the center of gravity is also the yawing axis, is what we use for the rudder, for making left or right turns using the rudder control, the rudder pedals over here. So you can see the rudder pedals for making left and right turns over here. So I use the size to control the rudder pedals for making left and right turns. We have also the nose wheel steering with the rudder pedals, the forward wheels of the aircraft over here. For nose wheel steering, you can steer it 76 degrees left and right, and this decreases as we increase for takeoff of the airspeed. So we have only the rudder after. So this is left and right control. The yawing axis. We have also this from wingtip to wingtip is the pitch axis, the lateral axis. So we use the elevator for climb and for descent of the aircraft, as you can see. So you can climb and you can descend like this, as you can see, using the horizontal tail of the aircraft. And flight. So we have also you can see the elevator, the pitch axis for climb and for descent. So we have also the longitudinal axis from nose to tail that transverses the other two axes. So this is the roll axis. We can make turns left and right using the ailerons and the spoilers like this. As you can see, left and right turn. The roll control or roll axis, we use the control wheel or the side stick in the Airbus. Also we use the elevator, the side stick in the Airbus also. So you can see the roll axis with the control. We'll make left and right turns using the ailerons and the spoilers. So you can use all controls together. You can see both the captain and the first officer are interconnected to move together in flight, unless you have a failure in the Boeing. All flight controls are interconnected. It's not like in the Airbus you have the side stick priority in either side. So we have also, you can see from the outside view, we have the thrust vectors from the engines, the Z plus from the Z engines that move the aircraft forward, and the pressurized air is coming off from the nozzle of the exhaust of the jet engine to push the aircraft forward. Also we have the fans in the front, and also you can see we have the bottom surface of the wings is more flat. As we take off, we have the flaps extended, and also we take an angle of attack that is positive. So we have using the Bernoulli theory of fluids, the airflow is moving slower below the wings, so we have higher air pressure, which pressurizes the aircraft weight and wings up into the air as we accelerate to like 140-150 knots and take off like 250 kilometers an hour. So we have also the top surface of the wings is more curved, as you can see. So using the Bernoulli theory of fluids, the airflow is moving much faster above the wings, so this creates lower air pressure, which sucks the aircraft weight and wings up into the air as we accelerate for takeoff. It's the takeoff speed. So we have also a couple things to see from the flight controls perspective yet. So I'm gonna show you a couple more things about the flight controls here. Another view of the flight control system, then I will show you the flight management computer. So from the flight controls also we have to see another view. I will show you also the outside view again, and then we're gonna make a flight plan using the flight management computer. Then we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. In the end part of the video you will see a manual flight, so stay until the end part of the video. So I'm gonna show you now this view of the aircraft flight controls. But you see here I'm having the side stick, the Lszh screen, 3D, also the view of the display. So you can see here also better view of the flight control system. We can climb, we can descend, make turns to the left, make turns to the right. The rudder pedals also. So you climb and you descend, you make turns to the right, turns to the left. Use the rudder pedals for nose wheel steering and the rudder control, also for toe brakes. So you can see the side stick deflection is proportional to the yoke deflection over here, as you can see. Left, right, horizontal trim stabilizer. Also we have the thrust control over here. You use the thrust levers forward and aft. You can see the thrust moving forward, thrust control over here. So you can adjust the thrust levers like 60, 70, 80%, 90, 100 when flying. So this is I will show you also the outside view of the flight controls. So this is climb, descent, make turns left and right, rudder pedals, and you see the outside view again. Make climb, descent, rudder pedals, and ailerons and spoilers like this, left and right turn. So hope you like the view of the side stick that I have. So this is all flight controls right now we need to know for steering the aircraft in the air or in the ground. So this is all for the flight controls right now we need to know. So I'll continue with the rest of the systems. I'll show you the thrust levers, the horizontal trim stabilizer, flaps, slots, speed brakes, alternate, pitch trim. So we move now with the flight management computer. I will input the data we need to create a flight plan or a flight path or a route. For this aircraft we're going to create a flight plan. So we'll input all the data of the aircraft for this flight. That includes the empty weight plus the passenger plus cargo plus the fuel on board, where the fuel is stored in the left and the right wing. We have 30% in the left and 30% in the right wing and 10% in the center tank. The flight management computer is going to calculate the center of gravity and the mean aerodynamic chord position from takeoff, climb, cruise, descent, approach and landing. We burn fuel, so the center of gravity is shifted because it's and is recalculated every second from the flight management computer. Also, this affects the aerodynamic chord position. Also, the horizontal trim stabilizer position. We have to pitch trim the aircraft differently, and also we have the stall speed using the mean aerodynamic chord and given angle of attack in flight. So you can see here we have to monitor the stall speed all the time. When we fly, you can see the airspeed tape, and it will show us if we are approaching the stall. This is given with a yellow number, yellow and red indication down here. So you have to avoid stalling the aircraft, increase the airspeed and pitch down if you have near stall. So we have also the flight management computer, other things to calculate. We're gonna use flaps 15 degrees for takeoff. We're gonna select the runway for takeoff, the Zurich International Airport Lszh runway 14. So it's gonna calculate the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air, and also the runway conditions. If it is ice, dry or wet, it will give us the takeoff phase, V1, V rotate and V2. So we're gonna have a V rotate and V2 like 140, 150 knots, 250 kilometers an hour approximately. So we're gonna pitch up the aircraft with 9 degrees or less for takeoff, also for landing. So we're gonna have the seeds also inserted in the flight management computer. The seeds are the standard instrument departure waypoints and fixes that include the horizontal and vertical navigation fixes and altitude and airspeed constraints for the initial climb and departure of the aircraft. We're gonna have to climb to the cruise level like 25, 36, 27, 29, 27, 28, 29, 30,000 feet above the sea level. So we're gonna cruise over there, make some turns, then we're gonna start the descent back to the elevation of the airport. So we're gonna be like 7 or 6,000 feet above the sea level, and we're gonna have the stars. The stars are the southern terminal arrival waypoints and fixes that include horizontal and vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing, and for the long and short final. So we're gonna have also the Lszh localizer, the instrument landing system, the Lszh localizer frequency for the horizontal localizer and the vertical glide slope receives from the onboard antennas of the aircraft the radio frequency transmitted from the runway threshold antennas of the Lszh localizer of the runway 14 in Zurich International Airport. So we're gonna have the Lszh localizer frequency. We're gonna use the magnetic northbound heading of 136 degrees for the runway 14. We're gonna be aligned for aligning with the runway position. So you're gonna see how we're gonna do that. So we're gonna have the horizontal localizer, the vertical glide slope. We're gonna use 25 to 30 degrees of flaps for approach and landing, 9 degrees of pitch in airspeed, 150, 160 knots. And also the landing gear extended, and we're gonna be approaching and landing manually the runway 14. So I'm gonna set the flight management computer right now. I will show you how to make a flight plan using the flight management computer over here. So I will use also this display. You can see we have the mouse pad. I told you, a nice view of the cockpit from here also. So we have the flight management computer. We can input all the data we need to create a flight plan. So also we have the identity of the aircraft, Boeing 787 GNX engines. So go back in the index, the position. We have reference airport Lszh over here in Switzerland. Runway, we're gonna use the gates and the ILS and the GPS position we can use for alignment. So we have either performance, takeoff, approach and unseat status, navigation data over here, flight plans, load traffic control, load plan, save plan. So we start with the performance here. Reserves 0 fuel weight, fuel on board and gross weight for takeoff, cruising altitude, cost index, fuel freezing temperature and center of gravity. So gonna use the route origin Lszh, Zurich International Airport in Switzerland. Copy paste and we'll continue with that. Lszh clear. So gonna use runway 14 for takeoff and for landing over here. So we have the route with blue, is not yet active. So we have departures over here. Select the runways. We're gonna depart 10, 14, 16, 28, 32. So we select runway 14, and we have the seats. These are instrument departure waypoints and fixes over here in the left side. Zui to Alpha. So we have departure and arrival. We can use the arrival over here. So we can use VOM 1628 34 ILS 14 ILS 16 over here. Next page, ILS 28 ILS 34 GLS 14 localizer 28 localizer 34. So we're gonna use ILS 14 trans Mickey for the approach and landing the starts. I'm gonna use the standard instrument departure, standard terminal arrival waypoints and fixes. We have the Negria 1 Alpha. So we're gonna use all these starts. You can see displayed here. So we have the route here, legs with blue. First one 136 degrees heading to nautical miles, 1,900 feet. Then we continue, change heading over here, Zui 6,000. Climb to the Nigria, Mati, Famiki, descend, approach and landing over here. So you're gonna see how we're gonna activate that with the altitude and the airspeed. So we have 0 fuel weight, 322,700. Fuel on board 34,300 pounds and gross weight 357,000 pounds. Reserves 5% over here. Cruising altitude 35,300 feet. Cost index 100%. Fuel freezing temperature minus 37 degrees. Cruising center of gravity over here 38%. And we can press the execute button over here that shows the green light on, and the route is activated automatically. 136 degrees heading, first waypoint after takeoff, 250 knots to 2 nautical miles, 1,900. TRO 95 098 heading 1 nautical mile. Then we have another one, 3 nautical mile 5. We make a left turn here, 052 heading 6 nautical miles, 301 knots, 6,000 alpha. Then we have Nigria. We make 071 heading 26 nautical miles from Zurich, 301 knots, flight level 22,200. Then we make a right turn, 230 degrees heading 12 nautical miles from Negria, 320 knots, 11,800, 258 heading Amki, 6 nautical miles from Maldives, 180, 10,400 Zui, 9 nautical miles, 180, 7,000 Alpha, Z8701, 6 nautical miles from Zui, 180, 6,000 Alpha, with descent, approach and landing here. For the runway, we have TR8 to 90 degrees, heading 10 nautical miles, 185,000 Alpha, CI14, 6 nautical miles, 184,000 Alpha. Here we make a left turn to align with the runway, 5 nautical miles, 174,000 Osnem. Then we have the runway 14, 136 heading, 8 nautical miles from Osnem, 140 knots, and 1,430 feet over here. So you can follow over here the waypoints one by one with the mouse also that I show you. You can make changes to the inputs. So we have over here flaps for takeoff 15 degrees, the takeoff reference, the thrust center of gravity automatic 28%, 4.25, runway position 14 V1, V rotate 128, 130, 140 V2 for takeoff, plus 15 knots, gross weight 356,000. So we have the takeoff over here, route, departure, arrival, other functions. Also we can use this keyboard, alternate, VNAV, progress, flight management computer, hold. We can select a waypoint and hold in flight, fix, and navigation radio can tune the Ilsloc localizer or the voice IDFs. We have the navigation aids for that. So you can see also we can have the air data computer over here. We have the GPS receivers, laser gyroscopes, pitot static, pitot dynamic, pitot the airspeed and altitude, inertial alignment of the aircraft with the laser gyroscopes, gyroscopic precession of the aircraft, and deceleration. So we can have all the air data, airspeed, altitude, pitot static, pitot dynamic, over here, and the GPS position, magnetic north pole is from the air data computer over here. So we have many things to see and talk about the aircraft. Over here you can see the flight plan we created right now. So you can see we have the waypoints over here. Use the mouse over here and select the waypoints we want to look at over here in the flight management computer. If we want to make changes, you can see we have everything displayed over here. The display of the flight plan from takeoff, the runway we use, climb, cruise, descent, approach, and landing. So you can see how far away we can fly. If we look further away, you can see here is Germany, France, and Switzerland. So this is the vertical also profile of the aircraft as we're gonna be flying over here. One waypoint by another, climb, then descent. Also how far above the terrain we're gonna be. So you see a little bit more clutter over here, center display of the flight plan. So maybe you see a little bit better the flight plan if we look closer. You can see the army key, some waypoints. Also here in the Lszh we have the display again of the flight plan. So you can look closer and closer. The center also display. You can see here we have the terrain in front of us with yellow and green and red indication. The runway, you're gonna see it in a more closer look. The taxiway in front of us, the other runway, the elevation of the terrain. We change the range. We can see the things around. So you see the taxiway is the one taxiway you have here in the GPS. Also the runway we use for takeoff and for landing. You look also outside for the terrain. If we have low visibility, we can look over here for terrain around in front of us when flying. So we have also the other over here display. You can see the runway, the heading, and the length of the runway, map setting over here. use also FIR over here, airspace display. So if you look further away with that, the flight plan mode, you can see here we're gonna depart, climb over here through these waypoints, then cruise over here, then descend, approach, make the right turn, descend, make a left turn, approach and landing over here in the airport. So this is all for the navigation purposes. We have I will show you also the engines display that I told you is controlled by the FAREX, the full authority digital electronic control computers. All the engines functions we need to know. Set up also the autopilot flight director system panel for takeoff, so you can set autopilot engage and disengage over here. You can see LNAV and VNAV. We have the flight director on, so we turn off the flight director, we will turn off the modes indicated. Auto throttle left and right over here. Airspeed, select the airspeed we need for takeoff. So I will set 253 for after takeoff. We have VNAV, LNAV and VNAV, flight level change, so the throttle climb continues. Heading, bank angle, autopilot disengage like this. The bank angle limit, heading, select 136 degrees for takeoff, the magnetic north pole heading. Vertical speed, flight path angle over here. You can set the vertical speed and flight path angle of the aircraft. So we have zeros, level off, we can descend like that. How many thousands of feet per minute you want to climb or descend, or hundreds of feet or tens. So we have hundreds and thousands, you can climb. You see the plus now over here indicator. We have also the altitude, thousands of feet, so we're gonna set how many thousands feet we need to climb, or I'm gonna set it like 35, and also hundreds of feet over here. We have our localizer, approach for auto land also. So a few more minutes left for this flight. So we have set now the airspeed over here, and the altitude from the autopilot is going to be displayed. The same for takeoff. We have the APU here. We're going to start the auxiliary power unit, a smaller turbine in the tail of the aircraft. It's going to provide us with electric power and pressurized air. If we turn off the engines, IDG, the great drive generator, 130 to 100 volts, 400 Hz frequency, battery, 48 amperes, primary flight control computers in the auto position, air data computer, flight control surfaces over here, power hefty door, power passenger oxygen over here, window heat, ram air turbine over here, hydraulics, left and right engine. If we turn off, you will see what happens. It will display fault over here, so we turn back on, then to the auto position. So we turn back on. We have the recorders, we have cargo and APU fire extinguishers over here, electronic engine control for the engine, normal and alternate mode, auto start. Over here we can start the engines. We can dump some fuel over here, fuel jettison, to lose weight if we arm this and select the nozzles and how much fuel to remain. We have the fuel booster pumps, left and right wing, center tanks. So we turn off and on the fuel booster pumps, fuel crossfeed. If we turn on, you can feed either engine with either pump or either tank, and balance the fuel between the left and the right wing tank. So this is the valves control. We have pressurization manual. We use outflow valves for climb and descent, pressurize and depressurize the aircraft cabin, and regulate the oxygen level. Also the air conditioning receives pressurized air from the engines bleed air system over here. So we have a couple more minutes. You will see all the displays here that I show you in the overhead panel in digital format. So you can see here we have hydraulics, the APU over here, oxygen and liquid cooling, electric left and right conductor drive, 130 to 200 volts, 400 Hz frequency. The APU is running with green symbol. You can see the main battery and the APU battery. 31 volts. The hydraulics, where the hydraulic fluid goes, which systems use hydraulic fluid. Primary in demand, left and right engine driven, shut-off valves 5100 left and right engine and electric PSI, and how much quantity you have in each tank, left and right wing and center fuel tank. Over here we have 11,000 and 11,000, 11,000 total, 33,700, 1,000 pounds low and high pressure fuel valves, left and right engine feed from the center or left and right wing. APU is fed from left wing using this motor. The cross feed valve is off, but we turn it on, can feed either engine with other pump or either tank. Also, you can see the fuel temperature. We recirculate automatically using the Farex, the fuel in flight. If we have freezing fuel, so the fuel temperature, the minimum fuel temperature minus 37 degrees, is gonna freeze in flight. So the Farex control the circulation of fuel and lubricant and oil from the wings and into the engines for heating up the fuel. So we have the pressurizer over here and oxygen. Doors are closed, cabin can be pressurized, landing gear, pressure of the tires and temperature of the brakes and the nozzle. Also, so you can see here we have the flight controls system, left and right wing, elevator, rudder, trim, also position. So this is flight controls, the hydraulics control of the flight controls display. Sensors, also we have FX display, maintenance system, circuit breakers over here, and last thing to see before making the engine start demonstration, normal menu checklist over here, before start, after start, before takeoff, after takeoff, approach, descent, landing. So we go back, navigation display, we turn off both engines over here. So we use the fuel control, left and right off, as you can see. So you can see the engines are off right now. I will display some warnings. So we look outside. Both engines are running out, so need to restart them very quickly. So we go in the overhead panel very quickly and start the auto start here, as you can see, both left and right auto start, yellow reconfiguration, amber warnings in the overhead. So now we have pressurizer from the APU, only pressurizer, not fuel yet, so we need above 20%. We have pressurizer, you can see pressurized only in the engines. We turn off, we turn on actually the fuel control over here, both left and right, fuel control on, and the engines are gonna start the auto start process. The Farex, the fuel authority, these electronic control computers, the controls, the monitors, all the displays here. So we have the auto start now. Also pressurizer, fuel flow to the engines, fueler mixer to the engines. So the auto start 50%. We have a couple of seconds. We go for takeoff above 60%. We're gonna have running engines. So this is running. So we use flaps for takeoff over here. Advanced thrust levers, parking brakes off, take the clearance from the air traffic control, and we're going for takeoff with the Boeing 787. So we taxi into the runway over here. We use the tiller control, so the air traffic control, the runway is open for us, there is no traffic, and we align with the center line over here, as you can see, center line position. So we advance the thrust levers over here to 100% full takeoff power. So we also use the rudder pedals for alignment. We press the yoke down until 100 knots, 70 knots, 80 knots, 100, 120, V1, We rotate over here, so we rotate. We have positive rate of climb. So landing gear is up over here. So you can see here all the data we need for flying the aircraft. You can see the airspeed 184 knots, the stall speed over here, the wind direction and speed, the terrain around us over here. We have 2,300, 2,400 above the ground, about 4,000 above the sea level. A climb with 5,400 feet per minute. The pitch altitude like almost 15 degrees right now. You can see also the terrain around us, the flight plan, the terrain below, the engines also. So if we look closer, you will see also the terrain here. Look the stall speed now, the red and yellow we need to avoid. So the terrain you can see with green over here, we are like 4,000 feet above the terrain level. You can see the aircraft symbol, how far above the ground we are. So this is all we need to know. Also the engines indication. So we keep climbing over here. So if we look outside, we need to start turning the aircraft around. You can see the lakes, the Switzerland over here, the Swiss Alps, and the runway behind us. So we're gonna make the turn now. We can leave the hands off from the flight controls like this. No problem, the aircraft keeps flying the way it should be, its direction. We have full takeoff power right now. So we need 14 more minutes for coming back for landing. As you can see, keep climbing. So we need to align here with the flight plan, with the air data. We have the engines also. A small turn to the right also. So here we are. You can see a beautiful view again of the aircraft outside. So this is the view of the aircraft, of the cockpit from inside after takeoff, as you can see. So this is also the outside view. You can see also the stars, the star sign. The lakes we're gonna cross through, it's already very close to us, and the France. So we're gonna have some very nice views over here from this place. Increase the range also, or decrease it if you like in the flight plan, so you can look better as we keep climbing. Autopilot over here, flight director, head-up display. You can see again the wind here, the airspeed, stall speed, the altitude we're flying through, the waypoints. So we have the Zui over here, the ground speed. We have the Zui intercept here, 3.1. We have the Zui after. Let's make a small turn to the left to align with the flight plan over here as we fly. So you can see the full flight plan here in this view as we're gonna be flying over here. So this is a nicer view of the aircraft here, the Switzerland, the lakes over here. I'm gonna be overflying the Germany, my homeland, the France over here. So we're gonna make a turn now for alignment with the flight plan as we climb. So we can leave the hands off from the flight controls without any autopilot. You can see the aircraft keeps flying the way it should be, has a positive attitude in flight, is very stable. So we have the LNAV here to align 30,000 feet, as you can see. So you can see also the waypoints here. So we need to start making the turn now, I believe. We have reached over here the turning point. The flight. Keep climbing, 31,000, 32 almost. So this is the turn point over here. Overflying the lake, the Germany, Bayern Munich. Over here. So this is the Boeing 787. Overflying the lakes actually, the Switzerland and other views. So we have also the chemtrails now as we fly, the frozen vapors from behind the engine's exhaust. So this is a beautiful view. Keep turning. Also use a little bit rudder, right rudder for the turn, as you can see, rudder pedal. Need also to increase the airspeed now. You can see we leave the hands off, no problem, from the flight controls. We need only a small input from time to time to the flight control systems, and this fly-by-wire aircraft we have horizontal trim also, pitch trim. We can use to increase the airspeed, the flaps up. We have reached the cruising altitude here of the data. We can go back for landing over here, as you can see. So we have over here with cruising, we have beautiful view of the aircraft, the Boeing 787 over here. Hope you like this view, the frozen vapors as we flying. We need to level off. So this is us, 26,000 feet. The frozen vapors, as you can see. Beautiful view. Over here the galaxy also. The Milky Way and the frozen vapors. And the lakes behind us. So we have the lakes, the Germany, Bayern Munich, my homeland, and the France over here. This way the galaxy. So we're going back for landing. Idle thrust and pitch down the aircraft. Speed brakes also. Extended. So we start the descent now to the elevation of the airport over here. As you can see, we are descending right now. Keep descending. This is a nicer view of the cockpit before approach and landing. We have 5 more minutes left for the video. As you can see, we are descending right now. For the video record to end over here. So we need to start the turn as we are descending. Idle thrust also. So make the turn now. We start the turn for approach and landing as we are keep descending. So this is the turn. For alignment with the runway over here, we have 3 more minutes for approach and landing for the video to end. So we are approaching, approach and landing. Make a small turn again. 2 more minutes left for the video record. Align with the runway over here, as you can see. Keep descending. Landing gear also down. So we are aligned with the runway. You can see the runway position over here. approach and landing view. And we have a couple more minutes before the video ends. As you can see, we are keep approaching. We're gonna have some flaps for approach and landing over here. Add some thrust, some airspeed also. Increase the rate of descent. So it's gonna be aligned with the Lszh localizer over here, as you see, for approach and landing. We have all the data we need to use. So add some thrust right now. We have some wind gas, some wind gas and also side wind to approach and landing to combat with. So it's making more difficult the alignment of the runway. So we have a few more seconds, as you can see. So here we have the flare touchdown, as you can see, beautiful touchdown. Parking brakes also in thrust reverse thrust. So we're slowing down right now. The aircraft is slowing down, as you can see. So we made a very beautiful approach and landing. You can see